All right, so today we're going to be talking about path traversal in our entry of applied review. Now, this one's a lot shorter, so you'll kind of see me breezing through these slides, and that's really just because while there is a lot of potential explaining you could do, a lot of it isn't really super necessary. Or when I say super necessary, a lot of it is more like what different payloads you might be using. But without any further ado, let's just go ahead and get started going through this. So first, we'll talk about, what path traversal, or it's sometimes called directory traversal, actually is. And basically, it's just a vulnerability that allows attackers to read arbitrary files on the underlying server that's running a vulnerable application. So this doesn't have to be a web application, but it could be a web application. And the reason that I have this picture of a cat inside of a folder bin right there is because in reading arbitrary files in the file system that's on the operating system that's underlying or that's hosting whatever this application is. That's what path traversal, directory traversal basically is. Um, and obviously, a lot of it depends on your circumstances and how you can leverage them. But in some cases, you can even get remote code execution off of some of these path traversal or directory traversal vulnerabilities. And it's really circumstantial, but it's definitely worth talking about. So without kind of dwindling a little more, let's move on to what this might look like. So imagine that you've got like your buddy's got a blog, and it's a photography portfolio of his. And so when you click on an image to, let's say enlarge it or something, you might have some HTML code like this, image source, load image, file name is equal to coolpicture.png. When it, when even though the URL is looking for, or the HTML is trying to find file name equals coolpic, file name actually resolves to var www images and then looks for this coolpic image. And the problem with that is, and you might even see it already just because I have these other screenshots included, but using that, you could just use the, escape dot dot slash characters to traverse out of the, so, dot dot slash brings you to www, dot dot slash to var, and then dot dot slash brings you back one more. And then you can look at etc password and even right here, it'll just take you back to that root directory, and you can just read other files. It sounds simple enough, and it really is simple enough. I mean, it's not super complicated, and there's countermeasures for this, and there's things we can do to get around those countermeasures. But without dwindling too much on that, let's go ahead and start with our first, little quiz. This is a hack the box machine called Inject that is just, it's basically going to be the same thing we just talked about. So I'll jump into that, and then we'll come back here when we're ready. All right, so now that we've got the Hack the Box Inject machine up and running here, we can go ahead and get started. If you run just a port scan, you'll find that this web page comes up. And we've got a couple options here, but the one that's most lucrative right off the bat anyway is download, or my bad, upload. And we can just browse for files here. I've got a cat picture ready to upload, and you'll see that it's uploaded, and it gives us a little link here to view our image. And in this case, it works fine. When I did it earlier in my testing, I didn't get it to work, but my image, it was from when I was doing malicious file uploads, so there was it probably wasn't a real image. But in this case, it seems to work just fine. So what we can do, right, is just try and do some path traversal. So let's just do 3. Let's see, password. And we get an internal server error. Okay, maybe that's not. Let's try another one. Okay, it doesn't seem to be working for us as much as we could have hoped. What I think we can do here is we can, I think, let's just try, and so if it's giving us a server error, I mean, at least it's not detecting this, right? So let's go ahead and turn on our proxy, and we'll make sure that our intercept is on, and we'll just go to view our image again, and we'll throw this in our repeater, same thing. And it's giving us a 500 again. Let's try just putting in one of these, and you can see, right, it's reading the contents of this directory for us, which is good for us, right, as attackers. We can keep backing out, main test, a few other files. Okay, a few other files. Oop, that's interesting. Oh, there we go. This looks like the inside of the var folder. And now we're at the root directory. So if we wanted to, right, we could read etc password like we were doing in the slides a second ago. And we've got a list of potential users. We see Phil right here. We see Frank. We could even go a step further, go to like home, and see what's there. Okay, we see two users, Frank and Phil. Let's go ahead and check out Frank. Okay, we see, nothing out of the ordinary, bash history, bash RC, cache. Local M2 seems kind of interesting. I'm not sure exactly where this comes from, but let's go ahead and see if M2 is a directory. Okay, it looks like it is. And we can read settings.xml. And just like that, we found a password for what appears to be Phil's SSH login. I wonder if this will actually let us log in with SSH or if we would have to. All right, so now that we've finished the Hack the Box inject machine, let's talk about some common countermeasures and workarounds. So obviously that last example was really, really straightforward. It wasn't that complicated, and it was pretty easy to pull off. So let's talk about, okay, well, what if they're actually blocking this dot dot slash character? If they can't stop us from inputting, or if they need our user input for something, why don't they sanitize it with something like this? And just think about it, if a website is blocking just the dot dot slash characters together like this, how might you go about exploiting that? And you might come to this conclusion quickly. It might take you a little bit longer, but here's a good example, right? If our web application is removing this dot dot slash, right? If we enter dot dot slash Etsy password, we're going to see that the clean string Etsy password isn't going to work because there's no Etsy password in whatever our current directory is. Makes sense, right? But if we enter this dot dot slash dot dot slash dot, or whoopsie, if we enter the 4 dots, 2 slashes, you'll notice it'll just take the first, or these dot dot slashes together, strip those out, and then shrink it together to just form another dot dot slash. So even though it's part of the blocked characters, it's because we didn't technically input these. We inputted this longer version of it. And because it's only getting rid of these dot dot slashes in the middle, you'll sometimes find sites where this is their countermeasure and it doesn't work too well. There's other examples too that we could go and talk about. One of them would be let's say you've got a website, right, where your file name has to be an image. So if we go back a couple slides here, let's say that it has to end in this .png. You might be able to put a null byte in between the file name you're requesting, like Etsy password, and the expected file extension, and that might also circumvent the logic that it's looking for. And obviously there's a lot of different logics that could try and prevent you from getting in, and there's a lot of different ways that you could get around those, and you kind of have to play it by ear. So there's plenty of payloads you can find online and plenty of payload lists. You might have to encode some things. You might have to just be clever and try to work around it, but really that's the basics of it, and the best way to kind of demonstrate this is again with another lab. So we're going to jump into 2 of these back to back. The first one is going to be Hack the Box Trick, where I believe we're just going to do some I think, yeah, for this one we can just do some encoding if I'm not mistaken, or yeah, it should just be encoding really similar to what we described. And then this next one, BroScience, is going to be a little bit more complicated, but still fairly straightforward to understand. So we'll go through those machines and then we'll come back here and talk about prevention. All right, so now we're chilling out here on the Trick machine on Hack the Box. It's a similar topic, but there's a few things that I skipped, so I'll just explain them. If you do some subdomain enumeration, you'll find this preprod-marketing.trick.htb domain, and then you'll be, just confronted here. If you look at some of these pages, you'll notice it's getting this page, or it's getting this HTML from this page parameter. So, we could try doing like that slash. It's not giving us an error, which is interesting. The last one gave us, the 500 error. It's also not telling us that it detected some kind of attack, which is kind of strange. But, it does look like it's filtering it out somehow because, even if we try like, we do a bunch, right? Maybe we're just really deep in a directory. We're getting nothing here. So what we can do is, assume, let's like we did earlier, that they're maybe cutting out just the dot dot slash. Maybe they're just sanitizing those, right? And that would make sense because it's giving us the same kind of result. So let's just try doing. I'll just do 4 dots and 2 slashes for each of these. That looks right to me. And just like that, we're able to read some files. In this case, Etsy password, so we can see list of users. We got root. Looks like there's some dude named Michael here that we might be able to take advantage of. Looks like there's some guy Michael here that we might be able to take advantage of later. In terms of our privilege escalation. There's also an SQL server running. So obviously, right, like this isn't the keys to the kingdom itself, but it definitely gives you a lot more information about the system that you're going to be targeting. So um, there's basically, the whole thing with this machine. Really, really short. Not that complicated, but definitely worth showcasing because it's one of the countermeasures, if you will, or it's one of the workarounds to a countermeasure that you might see at some point. So we'll go ahead and jump back and go to the BroScience machine once I've got it pulled up here. All right, and then last but not least, we've got the BroScience machine. So in this case, right, you run a port scan, you'll see that it's called BroScience.htb. It's HTTPS, so if you're running curl commands, you will need to uh, use like the -k argument to specify that it's okay, that this isn't HTTPS traffic and that it's all right. But we can go ahead and start looking for, obviously because we're doing it in this video, we know it's a path traversal kind of thing, so let's just look around. If we look at let's look at the seeded rows. And you can see like the exercise ID looks kind of interesting. You could also do like the images. And this is, I mean, it couldn't be clearer, right? Path right here. It's telling you that this is the path variable and that it's finding it from something. Let's try just doing a 1, 2, 3, 4. You can kind of see the history in there, and that's fine. But you'll see, oh, it detected our attack, so that's a pretty big travesty. Let's try doing the same trick we just did, right? Or 4 dots. Okay, that's not working either. It looks like it might be blacklisting these characters, or maybe there's a really specific whitelist that it's using. Let's try another trick, and we're going to try URL encoding it. I've taken the liberty of installing URL encode, which is just you can Google it, you'll be able to find this program. And there's obviously online URL encoders, but this is just the one I want to use because it's going to be the most like transparent example. So let's say we want to do. Let's just URL encode Etsy password here. And we get something like this. Let's go ahead and copy this guy and throw it up here. Same thing. Okay, it detects the attack. Let's try double URL encoding it. So you'll notice instead of the %2f, it's %252f. Let's try the same thing. Okay, so not an attack detected. Can't be displayed because it contains errors. This might be because, right, it's not an image. Maybe there's some backend code here in the web application that's ready to display an image, but we're not showing it an image. We're actually trying to read like a file like this. So, and to my knowledge, there's no standard images on just bare bones Linux, so we won't be able to test if that's true from here. What we can do though is just try doing like the curl command, right? So we can do curl. Let me grab this URL here. All right, copy. And like you'll notice, right, it has a self-signed certificate because it's HTTPS, so we're just going to have to go back in here and use -k to say that, we don't care that it's a self-signed certificate. And you'll see it reads the, Etsy password file just fine. So same thing, path traversal. It's in this case, right, it's we're URL encoding those slash characters, which the slash characters must be blacklisted. And maybe they thought ahead, right, and blacklisted the URL encoded. But if we double URL encode it, it does the same thing, right? So just another example of the same kind of bypass, but or a similar exploit, just a different type of countermeasure to the countermeasure that's in place. So let's go ahead and hop back in, and then we'll talk about prevention. Now that we've finished this, let's go ahead and talk about our prevention strategy. So ideally, you avoid passing user input to the file system API entirely, right? There's definitely a surplus of different ways that you could figure out how to serve the content you want to serve without needing to take input from the user directly or without having to take a user-controlled input. But let's say that, you don't have the resources to do that, or you can't do that, or, however it might be. Let's say that you just need to take user input. So first, you're just going to make sure that you're validating any user input before you actually process it. So, compare it to a whitelist, or, at the very least, validate the user input against a list of allowed characters. So don't allow the dots and slashes, don't allow the percents so that the null bytes could go through, and don't allow some URL encoded characters like we just saw on the BroScience machine. And then once you've validated some of that input, you'll want to append input to a base directory and use the file system to interpret that path. So that it's always in that expected directory. And so this Java code here at the bottom is just a good example of that. So your file is just, it takes two inputs, base directory and user input. Base directory should be static. So as long as this canonical path of the file starts with base directory, then you can actually process the file. But you shouldn't take this user input actually into the file name, or how should I describe it? The user input shouldn't be able to affect the base directory, and that's how you would go about trying to sanitize that input. But I mean, obviously, there's a lot more extrapolating you could do on this. There's a lot of different payloads that could and couldn't work in certain contexts. And really, what I encourage you to do is just go around and look for it. In your web app pen tests or your CTFs, just keep an eye out for it because it's a pretty cool and pretty low-hanging fruit. But as we mentioned earlier, it can definitely escalate you to a much more well-postured position as an attacker or or as a competitor in a CTF or as an attacker in a pen test. So yeah, that's all we got. But stay tuned for the next one.